So today we are going to give you the Matlab tutorial, and my name is Berkan. My office is AGC 254, the Computer Vision Hub, and my office hours are Monday 4 p.m. to 5 p.m. and Wednesday 12 to 13. And that's my email. You can also send me email anytime you want. The commonly used coding or computing environment in research is the Matrix laboratory, which is the Matlab, and this is an ideal tool for numerical computation. Also, it is very easy to learn. You don't need to compile any code, and you can test your ideas quickly. Also, it has a lot of extra tools which you can use for visualization. Also, you can execute the commands on command prompt without any compiling or anything. So Matlab allows matrix multiplications, manipulations, operations, and you can also visualize your data. You can implement your algorithms and create user interfaces. The default layout of Matlab looks like this. Here you have the editor window. So here you'll write your codes. These are going to be some M files. And here this part shows your directory. So if you have images or any other directories or M files, you'll see here. And here, this is your workspace. And you will see the defined allocated variables here. And also it shows their type and size and everything. Here you can write your commands. So sometimes for developing an application, you can just write some codes here and test the result here. So when you are sure that that works, these commands are already saved in the command history part. So you can just copy and make a code here. So next time you don't need to go to command window and run again and again, because you will already have them on the M file. So you can just run through the M file. Also you can do debugging here. So I will show most of these in the following slides. So here this is the current directory. So wherever your M files are, you need to set this clicking this button. Otherwise Matlab won't see your files. Or you can go to file menu and there's an option to add those M files to your path so that you don't need to be in the same folder. So the most important command of Matlab is the help command. So this is the Matlab. So and let me change this directory to my directory. Tutorial files. So now you see there are some files here. So this is my current directory. So you can write just help command in Matlab for any operation. Let's say you don't know how to use the sinus operation. So you just write help sine, for example, and it shows you the, let me make this. Can you see this part clearly or not? Yeah, so for example it says sine of argument and radians. And so also you can write help some operations, and it tells you about some operations. You can click and learn about these options. Another option you can get help is using this menu. You can click the product help, and you can write anything you want here, and it will show you similar functions which includes this name. So for example, you want to look at this one, so it shows you how to call it, and so it even has an example. So you can just copy this thing to your command window and you can execute it, so you'll get the same output. So let me copy it. So as you see, you get the same thing. So this is a figure here. So I write CLC all the time because I clear the screen. So you can also look at this help CLC. So it says clear command window. Also, you can clear your allocated variable. For example, here now I have the x variable, so I can just clear everything, or I can just also there are options to clean only some variables but keep the others. So let's go to presentation again. So the variables in Matlab are dynamically typed, and you don't need to worry about the types of the variables. So when you do some operations, they may change. And also I'll show you here some basic operations. For example, let's define some variables first. For example, let's define the variable a, and you just write it, and here you will see on your workspace the value. Or let's say you want to have a string, so you can just write it in this syntax, and now this is your view variable. So also you can change the type of variable if you want. Let's say you want to change this a to double, so you can just write like this and it's changed. So you can also change to integer, etc. If you want to define an array, you can just, let's say, write like this. So now C is this one. So also if you write C, it will show the output. If you put semicolon here, then it won't show the output, but it will still do the operation. So let's say if you do this, so you won't see the output, but if you plot it, you will see that it's changed. So also you don't need to have for loops for some operations on these type of arrays. You can just write like this. For example, d is equal to 5 times t c minus 2. So you just execute it and it gives you the output. Also you can use different operations. Let's say using the dot, it becomes, so you do the operation on each element, it's element wise. So now it's taking element wise square. So you can see this. So the vectors are the ordered set of numbers. So for example, you can define an array like this. 1, 2, 4, 5. Then you can look at each element just by putting it in you don't use the square brackets. In Matlab you use the regular parentheses. So the first entry is this one. Let's say the third entry is this one. Or you can look at the both entries like this, for example, let's say 2 and 3, and it shows you those entries. If you want to normalize an array, so you can just divide it by its sum. Let's say sum of x. So then, yeah.
Here also the array starts from the 0th index.
No, the zero index is not defined. If you do this, it gives you error. So everything starts from the 1. So if you want to do some vector indexing, let's say you want to create an array with consecutive numbers from 1 to 10. So in Matlab it's easy. You just write this way, so 1 to 10, and it generates it. Also, you may want to skip, like jump 2 every time, so you can just write 2 between the double columns, and you see this. So, also you can count the opposite way, for example. 10 to jump -2 every time, so go to 2, for example, or 0. That way you can create these. The vector addition is also simple. You can just, let's say we have an array, one is going to be, so as you see, I don't need to change the dimension of x. I can define x anytime I want, and so it doesn't need to be the same dimension. It was a 4-dimensional vector, now it's going to be 2-dimensional, but it doesn't give any error. So y is equal to 4, 3. So let's say I want to sum these and it will be my v vector. So I can just do v is equal to x plus y. So you don't use any for loop here. If you use for loops in Matlab, it will make your program much slower. So you'll always try to avoid some for loops. The scalar product, let's say you want to have, w is equal to a times v. A is 3 times v. So you can do it this way. Some operations on vectors. There is the sum operation. Let's say sum of, let's say Rx was this one, sum of x. Maximum of x, you can find the minimum, or you can find the average, which is the mean of x. So it gives you all these outputs. And you can also sort. Let's say your x is, let's say you have some z array which is going to be not sorted. So something like this. Now you can just write sort of z, and it sorts it. Also, you can generate some histogram. So it tells you which bean has how many elements. So in this one, every bean has one element. That's why it's it's like you don't see anything like Gaussian or something. The inner product, you can use the dot command for that. Let's say we had the x and y. So you can just do dot x, y. So it does this operation. So you can find the angle between two vectors that way. For example, these 2-dimensional arrays, you can also think them as vectors in 2D. So if you want to find the angle between them, you can use the dot product formula. So if the two vectors are orthogonal, then you will have 0. So let's say x is equal to -1 and 1. Y is equal to 1 and 1. So if you do dot product of x, y, it's going to be 0. So the matrices are actually, we usually in computer vision we usually use 2D matrices, because the images are 2D arrays. So you can, let's say, create a 0 matrix if you want, easily using this command, zeros of, let's say, 5 by 5, or 5 by 5 zeros matrix. So it creates that way. Or if you want, you can also create ones matrix. So it's going to be composed of ones. Or you can create some random matrices also easily. You can just use the rand command and you put the dimensions in it. So it gives you 5 by 5. The screen is small, that's why you cannot see it. So let's say 3 by 3. So you can get that way. And if you want to index, if you want to reach any of the entries of the A matrix, for example, you can let's say you want to reach this one, this entry here. So you will do like this, A of So here you count from here the rows, the 1, 2, and the column is 3. So you write 2 of 3, and you see that value here. Also, you can if you don't want to use two indices, rows and columns, then you can also use that way. So a of, let's say, a of 1 is going to be this one. A of 4, for example, is going to be 0.65. So it counts like this. It first counts here, then it counts that one. So if you want to do some matrix operations, let's say you have an A matrix, which is a matrix 1, 2, 3, and 4, 5, 6. So when you're writing the 2D matrix, you should use, or any dimensional matrix, you can use these semicolons. And the other one, like the first one will be one row, the other will be another row. So it's this way. Then if you want to do some operation, let's say B is 2 times A, for example, you just do this and it does this. So, or let's define B with another matrix. It should be 1 of 3 by 4. So now my first matrix A is 2 by 3. This is 3 by 4. So if you multiply them, you will have 2 by 4 matrix. Let's do C is A times B. So if you use C, you need to write for loops, do element-wise multiplication. In this one, it's so simple. So you can also, let's go to slideshow. So we did this now, identity matrix. So it's easy also. Let's say you want to create identity matrix X or something. So you can, or let me just not define any variable. You can use the I command. So you can write, for example, 3. So it makes a 3-dimensional identity matrix. So you can also change it if you want. The matrix transpose is also easy. You can just, let's say, this is your A matrix. You want to transpose it. So you just do this. Let's say C is equal to A transpose. So when you put this sign, it becomes the transpose. And you can also do the transpose of some of matrices or anything you want. The determinant is this way. So you have an A matrix, but it should be a square matrix. Let's say it is random, or not random, but let's make it some simple matrix. So you can just write the determinant and it computes the determinant for you. So let's make it a simple matrix. 1, 2, 3, 4. So as you see here, it's easy. For taking inversible matrix, you can just use the inverse command. So this was my A matrix, and this is the inverse of A. You can multiply A with the inverse, and you will see the identity matrix. So in order to prove that. So let me go to Matlab. In order to index 2 matrices, you can also you can do some matrix operations, like let's say you have a matrix from a 1D array like this. It's going from 102 to 150, jumping to every time. So this has 25 elements, as you see here, and also you can see here it shows the dimension like 1 by 25. So it's a one-dimensional array. So if you want to make it a 5 by 5 matrix, for example, you can just use this command: a is equal to reshape of a, and you write 5 by 5. Then it makes the 5 by 5 matrix. So that each, so it writes one column, another column, that way. If you want to, now I have a lot of variables here. If you want to know what variables are allocated, you can use the whos command. And so it shows you this one, like actually it's same as the workspace, but you can see it here more easily and clearly. So it shows the dimensions of matrices and types of the matrices. So if you want to find the, okay, this is not enough important. I can go to some image operations maybe. Or let's say, I'll show you some, this may be important. You can use this command, sub to int. This makes the linear index from multiple scripts. So let's say you do that, you write this one. 5 by 5. So you want to find what in this corresponds to a certain row and column. So you have 5 by 5 matrix. You want to find the 2 and the second column and the third row. So you write here and it shows you, you should call the 12th element. So a of 2 and 3 will be equal to a of 12 actually.
Is there an alternative to access the second row and third column? Like we used to do a bracket 2 comma 3.
Mm-hmm.
So that used to give you us the same
Yeah, same thing, yeah.
It's the same thing?
Yes, it's going to give you the same thing, a of 12, a of 2, and 3. So as you see, both of them have the same value. So I didn't show you this one. If you want to do element-wise multiplication between the matrices, you know, let's say you have an A matrix, 1, 2, 3, and you have a B matrix, now say 0, 5, 7. So you can just do that way. You put dot and then you put the multiplication operation. So it does element-wise operation that way. Otherwise, if you don't use this one, since the dimensions of, this will be the regular matrix multiplication, and it will give you error because the dimensions don't match. But so if you get transpose, then it makes some sense because the dimensions are changed now. So I'm going to talk about images, image operations now. So the images are also 2D arrays, and you may have a color image, so it will have 3 2D arrays, like let's say red channel, green channel, blue channel. Each of them will be a separate 2D array. But you will see in Matlab it as a 3D matrix. So the first entry will be row, column, and one of the channels, RGB. So if you have a grayscale image, you will have intensity values in Matlab 0 to 255. The 255 corresponds to white, and 0 corresponds to black. You may also have binary images, which are going to be just zeros and ones. So I can show about reading images. let's first clear this environment here. So this one is clearing your workspace, so there is no allocated variable anymore. Let me clear the screen. So I have an image here, as you see in my directory, which is the groceries.jpg. So I want to read that image, for example. I just write this, let's say image 1. So you can write any variable name here actually. You use the I'm read function, image read, and you write the groceries.jpg. So as you see here, it read and it's allocated. This is the number of rows, this is the number of columns, and it has 3 channels because it is RGB image, color image. So if you want to show this image, you can just open a figure, for example, and it's a blank figure now. You can write image show I1, and it shows the image here. You can click the points if you want using these menus, and you can see the intensity values, like red is 182, green is at 44, blue is 69. Let's say you go to some dark thing, so these values are low, and if you go to something white, these are all high. So this is showing the X and Y. There are a lot of options here. You can put labels, anything if you want, using these menus or using the commands of Matlab. We showed this one. This was the RGB. Let's say we want to see the red channel, so it is easy. You do this. So the red channel is actually this one. So if you put the columns here, it gets all the indices. So it means that all the rows, all the columns, and just the first channel, which is the red channel, because it is 3D, three-dimensional array here. You see, we just get the first one. So I want to plot this one, so I do this figure image show this one. It was I1, sorry. So this is the red channel. So as you see, the components which are red color are white. So but the blues are 0 or the greens are 0. So if you want to, let's title this one as red, for example. So you can write here title red. So now you see here there's a title here. You can also plot the other channels. Let's say you want to plot the green channel, and you title it green. So in the green channel you will see the greens are higher. Now did I change this one? Yeah. You can also convert a color image to RGB using this command. Let's say you want to call this new variable I2. So you write RGB to gray, and you write the name of the variable, which is the color image here. So here you see this is just a 2D array. It doesn't have 3 channels. And you can also show this one if you want. Where is it? So this is the grayscale image. And if you want to write this image, you can use the image write command. And here, when you open the parenthesis, it gives you feedback how to call the function. You write the name of the matrix, which is going to be I2, and you write some name, let's say test gray dot JPEG or bitmap, anything you want, and you write the format here. So as you see, there's a new image here, so that is saved. There is also the image SC function, which is doing some scaling and using some color representation. So let's say if you do image SC, the grayscale image, it is going to show these red points are going to be high values, and these blue ones are going to be low values, and yellows are the ones in the middle. You can put a color bar near it, and it shows you which color corresponds to which intensity. So the red is 255 and the dark blue is 0. If you want to look at the size of an image, you can just write size of I2. So it tells you how many rows, how many columns. It doesn't need to be image. It can be any type of variable. So if you had, x is 1 to 4, for example, if you write size of x, it also says it's 1 by 4. Or if you want to look at that three-dimensional image here, it tells you that it is three-dimensional. So if you want to know the number of rows and columns, you can write this way: rows, columns, and channel is equal to size of I1. So as you see, the rows, columns, and channel are set here. You don't need to initialize any variable. You can define variables anytime in Matlab. Thresholding. Let's say you define a threshold 128. So you want to find the number of the pixels which are higher than 128, and you want to threshold them. So you can first define an empty image here if you want. Zeros of rows and columns. And you can also define the type if you want here, that it should be unsigned integer. And you can do this. You want to index you want to just modify the pixels which are higher than 128 in this new defined I3 image. So you do like this. You find I2 greater than threshold. Let's say make them 255 or. And you can make the indices of I2 which are less than or equal to threshold 0. Then you can show the output here, figure, image show I3. So my I2 was here. So as you see, the high values are over the threshold, and the low values are lower than threshold, so they are zeros here, and the others are 255. You can change this threshold. So let's say you apply a different threshold, so you can do the same commands again here. Let's say not 128, but make it 200. So now there are less number of pixels which are over the threshold. The histogram of an image, you have the I2, which is the grayscale image. Let's say you want to find the histogram of the intensity values. They are from 0 to 255. So you don't need to do counting of like how many pixels are in what bin or something. So you just write the hist command here. So this is the histogram. So as you see, it's like the most of the pixels are around, in the range of 50 to 150 or so.
We cannot just do hist of I2. We have to mention the size.
This was 1D histogram. So when you do this way, it takes it as a, like, even if it's 2D, it writes it as a long vector. Then it makes histogram. Also, there is, I think, image histogram command. Let me try. So you can also use the image histogram. So this one works for the images. So you write the 2D directly here. And these are the intensity values. If you want also, you can specify the bins so that here every bin is, I think, every pixel intensity value is 1 bin, but you may also change, let's say every 10 interval is 1 bin or so. You can just write help command for any of these and it will tell you a lot of things for you. Okay, I did this threshold. There is also another command which is you can use image to black white. So this is doing binary thresholding, and you can write help IM2 BW, and it tells you how to do some thresholding. Let's say you want to do some thresholding. Let's define a variable here, IM2. This is called the I2, and you write the values or so. And it directly does the thresholding for you. So in order to do some averaging, you need a filter which is going to be a uniform filter. So you can define it this way. Once, it should be a once filter. So this 7 is big for here. Let's make it 5 by 5. So it's going to be this way, but you need to normalize it. So you just divide it by the sum of itself, which is going to be 25. And then you can use the convolution operation. So I think Dr. Shah showed this in the lecture. You can write your grayscale image here. You can write the mask you defined. And there are some options which are about the size. So we want the output to be the same size as the input size, so we write same. And this should be double. It's a warning. So then you can look at it. You can also write the number of the frame figure here. Let's say I write here figure 99. So it will open the figure 99 here. So let's say I'm showing this output here. I see. When it is double, you need to convert it to integer, because the image that way you will see just the white image here. This is the blurred one, which is because you do some averaging, you get a blurry image. if you change the size of the filter, let's say 15 and 225, then you apply the same operation. So you get even more blur. Closes all the open figures. Median filtering. This is also simple. You just write, let's say, image 6 median is going to be the median of image 2. So I write median filter 2. This is for the images. You just write your image here, and you write the size of median filter. Let's say you want to have 5 by 5 median filter, and it does the operation for you. So I'll show you how to compute some derivatives of an image. Let's say you have a matrix like this, 5 by 5, and you want to find the horizontal derivative, horizontal gradient. So you define a mask this way, F1 minus 1, 1, let's say, and F2 is equal to 1 and minus 1. So now I should put column here. Yeah. Then you can write just convolution 2 command here, level of M. You write the filter and you write this one. So my M matrix was this one, and this is the horizontal derivative. Also you can compute the vertical one. Into now this is going to be the vertical one. If these kernels are separable, you can also have another kernel which is going to be F1 times F2. So you multiply, it should be F2 times F1. These ones, and you can apply the same one, and you will get the same result. Now let me show you some image derivatives. Do I have some time? Yeah. Maybe I should go further. So Dr. Shah mentioned the F-spatial function. You can write help F-spatial to know what that function is. It tells you here what it is. So it says create predefined 2D filters. And you write the type of the function and some maybe size inputs, etc. And it can create two different types of filters, such as average filter, disk filter, Gaussian filter, or some Sobel private. You may use these. And it tells you for each one like how to use it. For example, if you want to use the average filter, you need to mention the size. For the disk, you need to mention the radius. For Gaussian, you need to put the size and the sigma. let's create a 7 by 7 Gaussian, for example. Let's say H Gaussian is equal to F spatial you write the type as a text string here. Now you need to define the parameters. Let's say it's going to be 7 by 7 and my variance will be 1, and it computes the Gaussian for you. And you can look at that one if you want using ImageSC function. So since this is 7 by 7, the center one is higher than the, it's a 2D Gaussian, and it goes smaller when you go further away from the peak point. And you can also have a 3D plot if you want. You can use the surf command, and it's going to show the Gaussian in 3D. The height is going to be the intensity. So at the peak, the intensity is high. So you see the peak here. If you look at on this plane, you will see the same image. Let's create a larger Gaussian, for example. Let's say 27 by 27, and let's make the sigma 3. So here this is going to be smoother because it is a larger filter. If you set the variance so high, let's say you put the variance 10, so your Gaussian will not be 0 around the borders, and you will see a cut Gaussian this way. In this way, if your variance is high, you need to make your Gaussian filter size larger. So in this case, if you do this one, let's say increase it, and then it will look good. Otherwise, you need to have these the values at the borders almost 0. Let's do some smoothing using the Gaussian function. F spatial, say 11 by 11. 1.5. This is an 11 by 11 filter with 1.5 as the variance, and you want to find I3, which is going to be the convolution of I2, and your Gaussian. So it is the blurred one. If you apply different Gaussians, if you apply larger Gaussians, you will have more blur. If you apply a Gaussian with just once, if you have just the peak, if this peak value is 1, the others are 0, you will have the same image. So let's do, what is this? Okay. Before this, I will show you some other things. Okay, the usage of for loops. let's say you have a random array here, 1 by 5. And I multiply by 100 because the random returns values from 0 to 1. So I want to make them larger, and I convert them to unsigned integer. So let's say this is 1. And this is the B, two random arrays. So you want to find the difference of them using for loop. Normally you don't need for loop, but let's say you want to use for loop. Then you define some matrix of zeros, and you can write a for loop that way. For, let's say I is from 1 to 5. Difference of I is equal to A of I minus B of I. And you write and here, so it computes the difference for you. If you leave these, if you delete this semicolon, you will see the output of each iteration. So let me make it. Let's initialize it. So as you see, it first updated the first, second, and third, and so on. If you don't initialize your matrices before the for loop, if you identify the difference array as 5 element, for example, it will, in the first loop it will allocate a one-dimensional, just a single value. In the second loop it will be 1 by 2, 1 by 3. So it will do memory allocation and deallocations, and it will still make your program slower. So if you have a for loop, it's better to set the sizes of the arrays before entering the for loop, so that the memory will not be allocated all the time. In order to repeat some matrices, there is the repmat command. Here I define a new matrix 1, 2, 3, 4, and I want to replicate this one. So I do this repmat A, and I write how I will replicate it. So I will replicate this 3 by 2, and so it puts A to, it's like a 3 by 2 matrix, and it puts every element to A. If you do 2 by 1, 2 by 2, it's going to be square. 2 by 1, it's going to be like this, 2 columns, 1 row, and it replicates the same thing. Generating random matrices, I showed you this one, let me show again. The random function gives you always a value from 0 to 1. And you can also put the sizes here. Say you want to find a 3 by 2 random array, and it generates it for you every time. There is a mesh grid command also. It may be useful. If you want to do some indexing or so, you can use it. It is this way, 1 to 5, 1 to 3. So it gives you the x and y positions of the matrix. So if you have a 5 by 3 matrix, 3 by 5 matrix, it gives you like these are going to be the x locations, these are going to be the y locations. This may be used when you create a filter or so. Let's say you want to create a Gaussian filter manually. So you may use this mesh grid, and it gives you some increasing number of consecutive numbers, and then you can just put those x and y's into a formula and compute the kernel. Reading video frames. Let's define an input path here. I had some frames I think here. Let me find this frame. Oh. It's in the other desktop. I didn't bring it. So, Oliver, do you have any directory with images? Oliver, do you have any directory with images on this computer?
Try pictures.
Is it here? Whatever. So I can just use this one. Let's say our input pad is this one. I write the address here. And if I want to find the elements in that one, in that folder, I can just write the dir command. And it shows you the files inside it. Or you can do just the, let's say, JPEG files. So it shows you the JPEG files. You may write this as a structure, let's say my list of files or something. And it's going to be a 3x1 structure here. Each one is going to be one of those JPEGs. It is sorted in a consecutive order. If you have like a sequence with the frame number at the end, it will have it as a sorted one. So you can see these list files. So one is going to be the first JPEG. The second one is this one, and third one is this one. So if you want to read some series of frames or images in a folder, you may write a for loop, and you may change the file name every iteration and read it using the image read function. So I'll give you an example here. Let me write it in the editor file here. So for I is equal to 1 to 3.
Size of list files will tell the number of images there, right?
The size of the list file, yeah. Yeah, but since I wrote the JPEG, you'll start at JPEG, it will just be the number of JPEG format ones. Yeah. Yes. Mm-hmm. Since I have 3 here, I can also write here the length of list files here. It's going to be 3 here. So for I from 1 to 3. Let's put some display flag here. So I can do string printf. And read. So here I will write the file name. So I can write it in column square brackets that way. I can first write the path, which I already defined here. It was this one. So rather than writing it all the time, I can just write it here, and you can write here /list files of I. So this list files, is a structure, and you need to use the name parameter here. So you'll write .name. So it will read in that folder as I is changing different images, and it will show you them. Let's write it here, I10 something, I10. I can also put some pause commands here, so that it will wait for the user to press a key. So it will show one image, and I'll press key, it will go to another iteration.